The easiest way to find DE is to make use of the fact that the triangles are similar, corresponding sides of a constant ratio, and we'll take a look at what that means. We are required to find DE, and the simplest way to do that is to make use of the fact that was given to us, that the triangles are similar. And what do we mean by the triangles are similar? We have a triangle ADE, and we have the larger ABC. Those are the two triangles. Using this principle, we need at least one known side of triangle ADE, of which DE is one of its side. DE is one of the sides of the triangle ADE. We need at least one side of that triangle in order to use the fact that is given to us, that the triangles are similar, in finding DE. What do we mean when we say that the ratio is constant? It means that if we compare mathematically the lengths of CD and ED, then that factor of comparison will be the same as if we compare AD to AB. However, for us to make use of the fact that the triangles are similar, we need at least one of the sides of this triangle, of which DE is one of its sides. And the easiest one to find is AD. AD is easy to find because we have the entire length here to be 8 meters, and we have here 3.2 meters. We have 8 meters and we have 3.2 meters. It is easy to see what AD will be. AD will be what remains when we subtract this 3.2 meters from this 8 meters. And that is 4.8 meters. Now that we have the length of one of the sides of that triangle, of which the side that we are required to find, which is DE, now that we have one side, then we may apply the fact that the triangles are similar. The ratios of pairs of corresponding sides are equal. So we take a look at corresponding sides. We have the two vertical sides. The vertical side here of the small triangle and the vertical side of the large triangles, and we have them highlighted. Now the side DE that we need to find, when compared to the side CB or BC, should give the same result mathematically as when we compare the sides AB with the side AD, the side AB of the large triangle with the side AD of the small triangle. The result should be the same because the triangles are similar. There is a constant ratio by which we may compare corresponding sides. No problem? 4.8 over 8. 4.8 over 8 is the same as DE over 6. We need to find DE, and all that we have is that 6 on the left hand side by which it is being divided. We will therefore eliminate that 6 that we have here accompanying DE by division on the left hand side. We will eliminate that 6 by multiplying by 6, the opposite of dividing by 6. And we cannot do anything to one side of an equation in order to change its value without changing the value of the other side in the same way. We therefore need to multiply by 6 on both sides. On the left hand side, to eliminate this 6. On the right hand side, to keep the equation balanced. Those 6 are eliminated, and we will reduce the fraction on the right hand side by a common factor of 8. 8 into 8 is 1, and 8 into 4.8 is 0.6. 0.6 times 6 will give us 3.6. And if we were paying attention to the fact that the triangles were 3, 4, 5, then after figuring out that this is 4.8, then if the sides are in the ratio 3 to 4 to 5, this is the 4 side. 4 into 4.8 would be 1.2, which is the 4 side. And when we get 1.2, we'll get the 3.6. Therefore, we could have taken a look at the fact that the triangles are 3, 4, 5 right-angled triangles in arriving at our answer. A clue to the solution of a problem may be given in a previous problem, or the implicit hint is geared towards a simpler approach. Always exercise presence of mind in an examination. What we mean by this is that the implicit hint is that the triangles are similar. But some students might not consider that that could be something useful in arriving at the answer to this problem. But as a matter of fact, we have solved the problem considering that the triangles are similar. That is a hint that is given in a previous section to this problem. But if students overlook that or do not pay attention to that hint, then solving this problem would take a lot more time. It is always good to exercise presence of mind in an examination. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.